Last unit, you guys solved proportions. You created your own and then solved them. Still going to talk about proportions today. Before I do that, I need a little quick review. I need a little help from you guys. Here's my classic proportion, right? Two fractions equal to each other. Do you remember what letters we called the means when we said the product of the means equals the product of the extremes? Which ones were the means, Henrik? C and B. And what were A and D called? The extremes. I'm going to show you a new proportion today. Where the what will be equal to each other. What's equal up here, the means or the extremes? The means will be equal. All right. That proportion when the means are the same number is called a mean proportional. Shocker, huh? When the means are equal, we're going to call it a mean proportional. All right. Take a look at my first example. Find the mean proportional between 4 and 16. Well, if the means are equal, what are different then? The extremes, and that's what the 4 and the 16 are. Find that number that I can multiply by itself that's the same when I multiply 4 and 16. So we'll set up our proportion. It's asking me for a mean proportional, which means the means are the same. So go ahead and plug an X and an X for your means. And then what are the 4 and the 16 acting as? Those are my extremes. That's a mean proportional. The means are the same. Okay, and you're trying to find that mean in this case. All right, cross multiply with me here. Let's get it started. 14, go ahead. X squared equals 64. Good start. So the mean proportional here will be what number? 11? No. Sort of no. Let me say that. Just not a hard no. Sort of no. Anybody know why? Hi, Claudia. Take the square root of something, you get left with, hey, if I plug -8 in here, -8 times -8 also going to give me 64? Yeah, so we're going plus or minus here. Okay, plus or minus because they both work. Plus or minus 8 for that mean proportional. Okay, but as you guys know, we do a lot of diagrams in here, don't we? And what can I not have as far as the side length? A negative side length. So most of the time, we're not going to deal with a mean proportional. We're going to deal with what's called the geometric mean, which is take the positive value. All right, now take the positive value only when I'm asking for a geometric mean. So in this one, find the geometric mean between 15 and 20. Still same method, except at the end, I only want the positive version for geometric mean. So somebody help me set up a proportion. Here we go, 27 in the house. Yes, no? All right, set it up. Find the geometric mean. So what's our mean should be what still? X and X, the means are the same. And what are my extremes? 15 and 20. So X squared equal to, let's keep this train going, 18. Oh, hey, Bill, how are you? Good to see you. How about 10? Not here. Look at this today, huh? 19. What's the deal? You got a calculator in front of you, Dylan. 300. Square root both sides, but I asked for simplest radical form here because we are an above average class. Biggest perfect square that goes into 300. 100 times 3. So your geometric mean here will be square root of 100, 10 radical 3. Not plus or minus anymore, because when I ask for geometric, I take the negative away. If I ask for mean proportional, Yeah, I'd do plus or minus, but that's all I'm looking for. 10 radical 3. Questions there? Means are always the same. Extremes are different now. All right, let me tie this into what we just finished, which are similar triangles. All I want you to do, you got a nice little area right there between the box and my requirements. Can you make my diagram for me? And then I'll start talking. All right, make the diagram first, and then we'll start talking. Okay, let's discuss what you just made here. What type of triangle is CAB? What type of triangle is CAB? That's a right triangle. All right. I am going to put a little marking on here. Everyone see you drew AD? Put this marking on there. It formed a right angle with the hypotenuse. Anybody name a vocabulary term for segment AD? That is called an altitude. Beautiful. We remember that. So I have a right triangle. Everyone agree? And I drew an altitude to the what of that right triangle? What's CB called? That's called my hypotenuse. So everyone see the diagram. I got a right triangle with an altitude drawn to the hypotenuse. How many triangles are in your diagram? 3. Let's talk about those 3. First, take a look at triangle DAB. And let's compare it to the big dog, CAB. They both have what type of angles in them? Right angles. And they both share an angle. Which one? Angle B. They both share. So they both have right angles. They share angle B. What can you tell me about those 2 triangles? Yes, they are similar. Everyone in agreement by angle. Beautiful. Next. Everyone focus in on triangle CAD and the big one. They both have what type of angles in them? Now they share what angle? What do you know about them? Whoa! So both the small triangles are similar to the big one. So what should I know about the 2 smaller ones then? They're also similar. Bottom line, what do you know about all 3 triangles in your diagram? They're all similar. Now, watch your mouth when I ask this question. If they're all similar, what do you know about corresponding sides then? They're in the same proportion. Now, if I asked you right now, hey kids, segment DB matches up with what in triangle CAD? I'd hear that silence for a while. Okay? It's tough. I don't blame you. Try to match up the corresponding sides. If I said, hey, CA matches up with what in the small triangle? We'd have some difficulty. And I don't blame you. So would I. So my goal today is to show you 2 devices that help you match up those corresponding sides. All right, I'm going to show you 2 small devices to match them up. Before I show them it, though, you guys got to be able to label the names of all these segments. AD, you already know. What do we call AD? Altitude. Let's label it the altitude. So that's the altitude. What is CB in this entire diagram? That's my hypotenuse. So we're going to call it the hypotenuse. Here's where I get real mathy now. If it's not the hypotenuse, what are the other 2 sides called of a right triangle? Oh, not bad. Legs. So we're going to call CA a leg. And we're going to call AB a leg. There's only 2 segments up here I have yet to label. What are they? CD and DB. Okay? The altitude cut the hypotenuse into 2, and this is exactly what we're going to call it, segments. So CD is going to be referred to as a segment, and so is DB. We got to know what each part is called, and I'll show you why right now. So how do I match up all these sides correctly? My first device to match them up correctly is called hills. No I. So if you want hills or whatever you guys say on the street, fine. Okay. Hills. That is your first proportion to match up the corresponding sides. How do I use it? Wild guess what the H stands for in hills. Nice. I'm going to put the hypotenuse length there. A guess what the L stands for. Leg. A guess what the other L stands for. The other L? Okay, we have to stop and talk right now because you might have a question. I certainly do. Anybody have a question right now? Go ahead, Thomas. Okay, well, the first question is which leg, because there's two of them, right? Usually it'll be one you're finding or the one you're given a length of. Okay, I probably won't give you a problem where you know both legs. Okay, so the only one you know information about. Good? I still have a question. Same leg or different leg? Same, and here's how you know why. What have we just gone over today? A mean proportional, right? Which you know what about the means? That's the same thing here. The means are the same. Always, when you set up hills. All right, the means are the same. What do you think the S stands for? And you're going to ask what? Which one? I got two of them. Great question. It is the segment next to, the segment adjacent to the leg we are using in the problem. So, quick quiz. If I am using leg AB in the problem, what segment should go with it? Which segment is next to, adjacent to AB? DB or BD, yes. Okay, so you use in hills the segment adjacent to the leg you're using. So these two values always the same, these two values always different. All right? Now, sometimes that's not going to work. You won't have enough information. So I got a second device for you. And you guys want to know why when we did congruent triangles and I introduced side angle side and some people calling it SAS and I got real heated and said, no, 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 because there actually is a SAS out here. Here it is. Here's the other device to match up corresponding sides. Wild guess what the S is. Yeah. A. Altitude. Other A. How many altitudes are in the diagram? Only one. And these are also the what of the proportion. The means, they're going to be the same. This other S for? So you should know the answer to this right now. Same segment or different? Different, because they're the extremes. All right? Every proportion you set up today, the mean should be the same. Mean should be the same. Anything on the whole hills and SAS before we start applying it? All right, let's see how you do here, kids. We got 3 questions to rock through. Let's see how well you do. Okay, don't do anything. Don't try to write anything down yet. Just please look at my diagram. Does everybody see a right triangle? The original triangle is a right triangle. Everyone sees it. Do you see an altitude drawn to the hypotenuse? Hey, those are the only diagrams you can use hills and SAS for. You can't just break it out when you feel like it. All right? Hills and SAS can only be used for a right triangle with an altitude drawn in. We're all good there. Let's get that. I'm going to force that one home. Now, the problem we're going to have, which one do I use? Is it a hills or is it a SAS? You only have one question to ask yourself. Ready? Is the altitude involved? Is it labeled? Is the altitude in that diagram labeled? No. So what can you not use then? Can't use SAS. So what's my only other option? Hills, okay? If the altitude is not labeled, you can't use SAS, so we're going to have to use hills here. Now I'm going to start calling on everybody. Be ready. The H in hills stood for what? 27? Okay, how long is the hypotenuse segment in this diagram? 12. Everyone see it? It's the 3 plus the 9. That's the hypotenuse. The hypotenuse of the actual right triangle is 12. What's the L stand for? 8. What's the L stand for? No 8. Of course not. How about 5? What's the L stand for? Leg. And the question was brought up by Thomas. Well, which leg? Well, what's the leg that's labeled? Y. So that's going to stay Y. Here you go. 19 in the house. What's the other L stand for? Leg, but it's the mean. So what's got to be going here? Y again. Ooh, now I'm going to need a stud for this one. 14. Hi, Caleb. What's the S stand for? But I have 3 and 9 up there. Which one? It's not really a preference. It's not really a preference. You pick the one next to the leg. Everyone see that? Why we're going to pick 3 and not 9. You pick the segment adjacent to the leg in the problem. And there it is. Means are the same, extremes are different. So y squared equals 36. I know I gave Fiona grief earlier because she didn't put the minus, but should I do plus or minus here? Why not? Diagram, side length. You don't need to show me you're rejecting it either. You could just put y equals 6. All right. Okay, next up. 28. How about 24? Okay, now I'm ready. Is the altitude labeled? Question's over. Done. It's got to be a SAS. It's the only one that involves the altitude. 26. What's the S? Okay, name one. Okay, we can start out with 4. You can start out with 12. 4 over 1 altitude length. X equals 19. What's on top now? 19. What's on top? X, same altitude, means are the same. What are you putting for the last segment? 15. What goes for the last segment? 12. The other segment. Extremes are always different. And you're darn right tonight on homework. Simplest radical form, please. X squared equals 48. Need somebody to break that down. 14. Can you help me break down 48? Biggest perfect square that goes in the 48. Nice. Times. Three. Finish that for me, Caleb. So the altitude is 4 radical 3. Any issues yet? Last one. 10 is the altitude labeled. Great job, 10. 25. It is labeled. So this is going to be a SAS question. Get the basics down today because tomorrow is going to come a lot stronger with these. 27. Give me a segment. S. 2. Over. Give me an altitude. 18. Give me an altitude. 3. Watch this one. 12. Give me another altitude. Good. There's only one in the diagram. A's got to be the same. Means are equal. And then what are you putting for the segment to finish this? 7. Great job. 22. X, yeah, there you go. I don't need it solved there. Stop showing off, Madeline. And there we go. 2x equals 9. X equals 4.5. Live this up now, because now, probably tomorrow, you might have to factor at the end, or quadratic formula. So we okay, comfortable. So you got bottom of the page. You got 3 questions out of the textbook, the review problem, all that can get done in the next, you guys almost got 20 minutes here. So let's get it going.